Good morning, everyone. Yeah, this is Devendra Rajput from IEEE Computer Society chapter, and I welcome all of you here for this technical webinar series. And today's topic is what needs to be in place before AI. We we haven't got permission yet from the speaker. She will review, as we said, that she will review and she will say that is there any proprietary information is leaked or not. After the review, we will make this video available to you. So we are recording it. So please, audience, don't record if you are willing. So we will share after the session. Let me give you the session flow. So I will quickly introduce speaker and co-host. Our speaker will give the presentation around 35 to 40 minutes. We will have a separate 10 to 15 minutes Q&A session, but speaker is uh, okay to raise your hand and she wanted to be more interactive. So if you have any questions on the topic, you can raise your hand and she can take your questions in between the time. And if you have any technical difficulties, you can put those into the chat and Alan will help you to solve those problems. And towards the end, we will have a closing remarks. So this event is organized with the co-hosts listed here. We can see our Computer Society Richmond chapter brings computing professional researchers, students, and practitioners who are passionate about advancing the theory, practice, and application of computers information processing in our region. We regularly host our technical talks, networking sessions, and community activity to support continuous learning and professional growth. You can see IEEE Women in Engineering, Young Professional Affinity Group, Santa Clara Valley section. So one of the most active community in the Silicon Valley is known for the rich scheduled seminars, workshop, and collaborative technical events. And there are Central Virginia, Northeast Florida, uh, Affinity Group, Computer Society chapters, and Virginia State University student branch. So thank you all of these chapters and affinity groups for joining hands to make this online session possible. It's my honor now to introduce you our distinguished speaker, Ms. Malar Kondappan. She is a lead system architect and technical project manager with over 2 decades of experience building cloud-native platforms in insurance and financial technology. She specializes in API-driven interoperability and large-scale integration architecture that supports high-volume, highly regulated insurance ecosystems. Malar has authorized peer-reviewed articles on API integration, cloud computing, security consideration in modern insurance platform. Her paper on impact on AI insurance platform integration is under review in an international IEEE conference. Malar is also a book reviewer for BPB publications, A Press, and Orally, covering the topics insider threat security to mastering Azure and cloud platforms. She serves on technical programs committees as a reviewer for multiple IEEE sponsored and international conferences. She is a senior IEEE member and a fellow of Hackathon Raptors, IET, and Sigma 11. Malar has also served as a judge in global award programs, entrepreneurship competitions. She mentors and judges teams, coding competitions, hackathons. Her recognition includes multiple international and organizational awards for cloud transformation, innovation, and digital platforms. Malar is also passionate about mentoring and STEM outreach. She has spoken in Women in STEM speaker series and her career in cloud integration engineering for young women, and she supports regional STEM career events throughout the professional and engineering organization. Academically, Malar holds two master degrees, a Master of Science in Information System and Security, and a Master of Computer Applications. Malar is Microsoft Certified Associate and .NET Development Integration Technology and Generative AI Fundamentals. She is also recognized as a trusted lead architect who turns ambitious business vision into robust, secure, and scalable technical realities, bringing together cloud integration and artificial intelligence to reshape modern insurance technologies. With that said, let me once again welcome our speaker and invite Ms. Malar to share her experience on the topic, what needs to be in place before AI. Thank you.
Hey, thank you, Devendra, for the kind introduction. Let me share my screen. Can you all see my screen? Can you all see my screen?
Yes.
Yes, we can.
Thank you. Thank you. Thank you, Devendra, for the very kind introduction. Good morning, everyone. Thanks for being here. I want to start with a few important disclaimers. This is an educational content, and anything that is all based on industry experience and publicly available research. Nothing I say constitutes legal advice or regular guidance or professional recommendations for your specific organization. The views I express are solely my own and do not represent and shouldn't be attributed to any current or former employer, client, partner, or affiliated organization. The insurance and AI regulations vary significantly by jurisdiction. So before implementing any practices discussed today, please consult with your legal counsel, compliance officers, and relevant regulatory bodies. So with that, I'll go to next. So Devendra has already introduced about me, so I want to keep it short and I want to give you what we're going to do today. So today I'm going to share the patterns from my hands-on experience with real-world systems and the lessons that we learned from failures and successes at scale. I'll walk through 4 pillars: data, architecture, governance, and people that I've seen enable this machine learning algorithms or any AI technologies to succeed when properly implemented. So here's the thesis. AI failures are an algorithm problems. I see them as a plumbing problems. So my focus has been building the foundation underneath the AI systems, the data pipelines, the APIs, the audit logs, the deployment infrastructure, the governance frameworks. So the real systems, real outcomes, and the real mistakes learned from. So let's dive in. So before we dive into solutions, let's just do a ground check reality. So according to MIT's 2025 GenAI Divide report, only about 5% of enterprise generative AI pilots show measurable business impact, leaving roughly 95% with little or no clear ROI. More broadly, industry research consistently shows the most AI pilot projects never make it into production at scale or fail to demonstrate the clear ROI. Deloitte's work on the enterprise AI adoption indicates around 200 insurers were surveyed that many organizations struggle to move from proof of concept to operational or the production grade AI systems. The BCGs, which is very specific on the insurance leads in AI adoption, there only 7% of insurers have scaled AI across their organizations, while roughly 2/3 remain stuck at the pilot stage. So several structural issues show up again and again in a failed deployments. One example comes from publicly reported industry cases. In 2023 and 2024, the insurance claims automation systems that were deployed without sufficient explainability and governance faced significant regulatory and operational challenges. Thousands of claims were initially denied without adequate explanation or audit trials. On appeal and regulatory review, the vast majority were reversed or modified. So this triggered lawsuits, regulatory investigations, and more importantly, the reputational damage. So the lesson is clear. AI systems that lack explainability, audit trials, and human governance can fail very publicly and expensively. So the result is not just the failed projects, right? But the lawsuits, the regulatory actions, the customer harm, and the reputational damage. So why do these smart companies still fail? So let me walk you through the most common failure modes that we have seen in the production AI systems. So what went wrong in these cases? So the organizations deployed AI without the right foundations. The first is the data silos, poor data quality. So the data is siloed across systems with inconsistent definitions, formats, and timestamp standards. When you train an AI model on this fragmented data, it learns from conflicting signals. The model may look sophisticated, but its predictions are classic, what do we call today? Garbage in and garbage out, because the input data was never trustworthy to begin with. The second is a legacy architecture. So many organizations try to bolt AI onto monolithic and batch-based systems, and they're all designed 20 plus years ago. And this is pretty common in insurance, right? Because of mergers and acquisitions. So there's no clean way to deploy a model or monitor in production or update it safely. So the AI team built something technically impressive, but that has no realistic path to production. It stays in the lab. So the third is a no governance or explainability. So the model makes decisions, but no one can explain why. There are no audit trials. No one knows what data fed the model, what logic was applied, or whether the systematic bias exists. So when regulators or customers ask questions, the company has no answers, which quickly becomes a compliance and a liability problem. So the fourth is a lack of business alignment. So the AI team optimizes for technical elegance, building what is scientifically interesting, but not for a problem the business actually cares about. Or business stakeholders do not trust the model, so it sits unused. So without alignment between the AI, the product, the business outcomes, even technically excellent AI produces zero value. So what is the lesson we want to take here? The AI, without proper foundations, becomes an expensive and risky failure. So what are these foundations? I would like to start with an example from the real world business use case, the insurance quote comparison platforms. So before I start anything or show anything, how many of you have used a site to compare car insurance or travel insurance quotes? Great. Thank you. Yeah, so it's so simple, right? When you start typing your details into one of those forms, do you have any idea what do you think is happening behind the scenes? Have you ever guessed about it? So these platforms operate at a very serious scale and complexity. There are multiple carriers. You type your information once and you see the prices from multiple carriers, the insurers, and it all given in some pleasing order for you to get attracted to so you can go further and go through their site. So you won't be pleased if you're only seeing like 4 or 5 prices on the platform. You want to see more so you can compare and make your informed decisions. So there are multiple carrier integrations. The price comparison means querying and aggregating quotes from dozens to hundreds of carriers in real time. It's a high volume traffic. So millions of customer interactions are here hitting those APIs. And it's a highly regulated environment. The state privacy acts are everywhere. Every state has a consumer privacy act. And we should have a very clear audit trail on every request and response. It has to respect the state insurance regulations, the consumer protection rules, and in some cases, it's a fair lending style expectations. And the technical requirements have to be well sophisticated. Real-time data pipelines, low latency orchestration. What do I mean by that? We can't make the customer to wait for minutes. They need the responses in seconds. So that low latency orchestration is a key. And the decisions that we make by giving them those prices have to be really explainable if a regulator or a partner asks why, right? So I have worked on the technical architecture projects in this space. The specific details, the company names, the finance metrics, carrier counts, revenue figures, those all belong to those organizations and stakeholders. But what I can share and what's useful for you are the foundational architectural and governance patterns that made these platforms scale safely. So the principles are universal. The industry can vary, but the implementation details can be different, and the common foundations are the same. So as we go through the pillars, keep asking yourself, Which of these is strongest in your organization and which one is your weakest link? That's where your AI program will fail first. So let's start with an overview on the price comparison process model. I want to give a behind the scene picture on what happens between you enter the data and you see the price. So behind every code comparison, you see those multiple steps happening, right? And all these happens within seconds. So you don't know all these metrics and the processes that happens to get you the price back to the screen. So let's start from left to right. So there's a lot more going on the price list than a price list what you see on a web page. So let's walk through what actually happens. So the data comes in when a customer fills out that long form. But how do you trust like all the data is valid, right? Exactly. So the first job is the validation. We check formats, ranges, mandatory fields, and reject any bad input before it pollutes the downstream systems. The rules kick in, the state-specific regulations, the coverage rules, the business logic, it's all applied on the same way at the entry. And the carriers get the identical questions. Here's where the data integrity comes in. We have to represent the customer in the same way to multiple carriers. When we call these carriers in parallel, each carrier gets the same customer data. And when the responses comes back, we need to stitch it back together. Every quote is tied back to the carrier, and we need to make sure the lineage exists. Starting from the customer data to the request that we sent, the response that came back, it's all the moment of truth. So as you see, the data is created as every step with consistency, accuracy, and traceability. That's why pillar number one is the trustworthy data. If the data foundation is weak, every clever model you put on top will eventually fail. So there are some still data challenges in this insurance price comparison model. We'll get to see about that. But at least this gives you an overview on the business model that I'm going to use as a use case as we proceed further. So this gets our segue to pillar one, data standardization. So what is the messiest part that I was talking before? It's the carrier data. As you see on the left, the carriers is all in different formats, right? So different carriers describe the same thing in completely different ways. So the premium can be monthly or annual or quarterly or semi-annual. The coverage labels, they all jump between the liability, bodily injury, or a third party. Fees, the installment fees are sometimes included, sometimes bolted on at the end. Timestamps, they are in different time zone and format you can imagine. So quick question to you all. When you dump all these data straight into a ranking model, what does it learn? The data format is completely different. It's going to be stress on the model to interpret this and then apply whatever that the model we have implemented for. So it's not the learning patterns, right? It's comparing apples to oranges and to pineapples. If you have more carriers, it's more comparisons, it's more data formalization. So your analytics and AI fail not because the algorithm is bad, but because the inputs don't mean the same thing. At any serious integration scale, you hit this wall, and there's only one real way through it, and that is data standardization. So what you see on the right is the canonical schema, one unified data model. The premium is always the same unit and currency. The coverage types all use the standard codes. The timestamps are always UTC or whatever the standard time zone that your organization wants to set up. So no exceptions, no special cases. And how does this all possible? We need to have a mapping layer introduced. So for every carrier, we need to make sure the data translation works great. For example, when we say coverage 100-300 limits, the carrier's liability field maps to our standardized coverage code, bodily injury or BI. And with this transformation, when something looks wrong in production, this mapping is what saves you. And when you want to add more carriers onto the panel, you have a template that to follow, and you establish those mapping rules and transformation. And not every carrier response is given back too, right? So there's a validation you need to do at ingestion. If the carrier is sending you a negative premium, we filter it, and we just show only the price which are valid. And we make sure to stop the bad data at the door. It never reaches your warehouse or your models. So the payoff is the full data lineage. Every number in the system can be traced back to where it came from. So when a customer or a regulator or a CFO asks you, where did this number come from? You have your answer in seconds instead of and investigation. So this is not a nice to have data project. This is a foundation for trustworthy AI. If you skip this step, every clever model that you build on top will eventually fall over. So far, everything making sense before I jump on to the next pillar? Great. Thank you. So the next pillar that I want you to see where AI actually scale is our pillar 2, modern architecture. Modern architecture for AI boils down to one essential insight. Your machine learning model or your agentic model is just another microservice. It consumes input data, it produces a prediction, it gets versioned, deployed, monitored, and rolled back if needed, like any other service. So why this matters? If your underlying architecture is monolithic and rigid, every new model becomes risky. If your architecture is modular and observable, AI is simply another capability you plug in, test, monitor, and iterate on. So think of the AI model as just the tip of an iceberg, and the modern architecture, the massive structure under the water that actually keeps it stable. The model, what you see on the top, is just the 10% of the iceberg. The other 90% is the modern architecture that keeps it afloat and safe. So what does this look like in practice? API first design, API contracts, the versioned APIs. If any logic needs to change, we just change the implementation underneath and we just have those plugged in back in and it continues to work because the contract the same. Microservices, not a giant monolith. Trust me, monolith are not bad, but if the monolith is having a cross domain, that becomes a complicated. Real-time orchestration. At scale, when you receive tens or hundreds of transactions at the same time, the system has to respond under a few seconds. It's a well-coordinated, real-time distributed execution. Observability, it has to be everywhere. Data is gathered at every step in the process, so the metrics, the logs, and the traces of every component and every decision. So that level of visibility is that the operation team needs. That's what the business needs. They want to know how did we perform. They can't go blind, right? So connecting back to the iceberg analogy, if the base is weak, the visible tip might look very impressive in the demo, but it will crack the first time you push it to production. If the base is strong, you can reshape or grow the tip over time, new use cases, new models, but the same solid, strong, scalable foundation. That's the pillar number 2 of modern architecture. Any questions so far? Are we good? Are you all still with me? Thank you. So I want to show you a common architectural pattern where this machine learning is in a regulated real-time systems. So this is my generalized illustrations of industry best practice. Any resemblance to a specific company implementation is completely coincidental. Okay, so think about this as a system like an insurance code aggregation, a machine learning. I see this machine learning appearing in 2 logical layers. The layer 1 is a candidate selection. What do I mean by that? So when you have the insurance carriers, there are too many insurance carriers in every state, right? So you need to be very choosy about to whom you want to send this request. Before we fire off expensive carrier request, a model has a capability, if you implement it well, decides which carriers to request based on the customer profile, the location, the risk factors. Why? Because calling every carrier, if you have 70 or 100 carriers in every state, calling every carrier every time is slow and expensive. The smart filtering cuts that latency and cost because the response has to be in seconds. The layer 2, where I see the implementation of this machine learning or any AI agentic workflow, is the results ranking. So once responses comes back from the carriers, this model would score and rank the options, because when you see the prices on your list, you need to be seeing someone on the top, like top 1, top 2, top 3. It would help the customer to make the decision. And how the decisioning should be, you need to find the best model for the customer and also the best customer for the carrier, who are most likely to convert, which are most profitable, and which best fit the carrier profile and the customer profile. So how does this stay compliant and auditable? Both models are treated stateless, deterministic services. Model shouldn't care is a person X or person Y. It has to be validating on the profile. So it has to be taking that as a customer profile with the good driver background or the accidents or incidents. It has to be taking those as a profile and also study the carrier performance, like how did the carrier perform on these kind of a customer. Some carriers like high risk profile, some carriers can only quote low risk profiles. So the performance and the predictions will define who will be benefited out of this. So how does it do? They read the features as a central feature store. They generate a decision. It's all de-identified data, no trace of the customer PII. And we log everything at every step. Which carriers were selected, which features were used, what scores were produced, and what the final ordering the customer actually saw. That log is what lets you explain any outcome to a regulator or to a customer or to an internal auditor, even to a carrier, like why I wasn't listed top one in the price, how many times I got listed in the top three, right? So here's the key insight. The machine learning models, what you're seeing in this picture, in this complex architecture or this illustrated architecture, are just two boxes in two different layers in a much larger system. So what we need there, the data engineering, the pipelines, the schemas, the validations, the platform engineering, APIs, deployment, monitoring, governance, you have to log, audit trail, compliance, and cross-functional alignment, all these things to work together. That's 75 to 80% of the work. The model themselves are maybe 20 to 25%. So when you invest in that 80%, the data, the architecture, the governance, and the alignment, the machine learning or any AI agentic workflow becomes something that you can plug in, test, monitor, and defend. When you don't, the exact same model becomes a liability. Is that helping so far? Great. Thank you. So I would like to switch gears and talk something that is far less glamorous than models, but absolutely non-negotiable. So our pillar number 3 is governance. So in insurance, regulations vary state by state, product by product. The regulators don't care if your model is clever. They care if you can explain it and it's fair. So in the US, the insurance regulators, through groups like NAIC, if there are any insurance folks in the group, they know what is NAIC is. So NAIC is a National Association of Insurance Commissioners, and they are publishing guidance on how insurers should govern AI. The details differ by state, but the direction of the travel is very clear. If you can't explain and if you can't control it, you shouldn't be running it in production. So what does good governance actually look like in practice? Let me walk you through a concrete scenario. A customer calls, they ask, why did I see these 3 insurance options and not the others? Because I know these insurance carrier coding in this state, but I don't see them on the price list that I got. So in a well-governed system, here's what happens. You pull up their request, you'll have a track ID, and you see exactly which carriers were selected and why, what features were used, what model version was used, and what's the scoring we got on that carrier. And you see why, which offers were ranked first and second and third, and why. The price, the coverage quality, the customer profile, the brand rating, the predicted conversion, and whatever factors that drew the ranking. So you can walk the customer through the entire chain, data in, features, model, output, display. In an ungoverned system, you open a ticket and you hope for someone to remember all these processes, right? So what you see on the screen are like 5 or 6 different features that I want to talk about this AI return governance. I'll make sure I won't bore you with all the details, but I just give you an insight. The first one is a written AI governance program. A real document that spells out who owns which models, how are they approved, how are they monitored, and is it getting revised, and what is that model is supposed to do. The real model documentation, like every process documentation, you need to have documentation on these model and the audit trials. For every model, you should know what problem does it solve, what data was it trained on, how well does it perform, where does it struggle, and for every prediction, you should be able to reconstruct the input data, the features, the model version, the score, and the timestamp. Third is a strong data security and access controls. AI model is nothing different. So the data in transit has to be encrypted, Data at rest has to be encrypted. The access is role-based. So the analysts see the aggregates. The modelers work with the feature engineer views like the de-identified data, and only a very small, well-defined group can actually touch this raw PII. And every access is locked. So the fourth is a model transparency. Explainability has to be built in, not bolted on. Your model shouldn't be a black boxes. If you can't explain it, you cannot defend it. So the fifth is a bias testing. On a regular cadence, you test or certain regions, the customer segments or the profiles consistently getting different outcomes. Is that difference justified by risk? Or is your data or model is introducing an unintended bias? Bias work is not a one-time certification. It is an ongoing quality control. Every day you receive thousands and millions of data that needs to be again de-identified, fed to the model, and needs to be revised and tested. So it's an ongoing process. Why does all this matter? Because in the regulated industry, insurance is a highly regulated industry. AI without governance is not an innovation strategy, it's a liability. You're dealing with personal data. Your system influence who gets access to a critical product, on what terms and what price. The companies that are winning with AI in insurance have one thing in common. They can explain, they can audit, they can defend every decision their systems make. And note, whatever I said is educational and not a legal advice. Your exact compliance requirements depend on your state, your products, and your licenses. The goal here is to give you a concrete picture of what responsible AI actually looks like in your world. That's our pillar 3 governance, my friends. And the next one, before I switch to, hope it's all good. Thank you. So the next one and the last pillar is organizational alignment. You can have great data, modern architecture, and tight governance, but if the organization is misaligned, AI still fails. Here's what failure looks like. So the data teams works in isolation. They build a very beautiful model. Business doesn't understand it. They don't trust it. They can't plug it into the workflows, so it never ships. Or it ships and nobody uses it. Or the opposite. The team optimizes the metric that nobody cares about. 6 months in, you realize the business has no way to operationalize the model. Or worst case, the model goes live, but no one owns maintenance. Data drifts, performance quietly degrades. The first signal that you receive is from the unhappy customer or a bad KPI. So how this could actually make work? The cross-functional teams with the shared ownership. When you go from left to right, the first one, the product, business, they define the problem, the success metrics, and the customer context. What are we actually solving? And how will we know it worked? Engineering owns the deployment, safety, and monitoring. Is a model running reliably? Are we catching the data quality issues early? The data science owned the model and performance, retraining cadence, fairness testing. Is this accurate? Is it drifting? Is it introducing bias? The compliance owns the regulatory risk and fairness review. Does this align with our applicable regulations and internal policies? Business and finance owns the ROI. Is this actually improving the target metric enough to justify ongoing investment? This is very important. So everyone is at the table from day one. Everyone owns the result and not just some dedicated AI team. So I want to give you a scenario where you can correlate this. So consider a scenario where the model optimization is needed to improve the cost efficiency. So the business and marketing team starts by defining the target customer segments, guardrails, budget constraints. They knew which channels were profitable and which ones routinely lost money. So what do I mean by channels? The business has different marketing campaigns. They have a way of acquiring leads through email marketing or through promotions or through advertisements. So there are different channels through which they are spending money to get more customers to their industry, right? So they would have a clear-cut metrics on which channels were profitable, where did we spend the money, and what the outcome was. So the finance sets a clear bar. If this doesn't improve our key metrics by at least X percentage, we stop. Now the data science team has a clear direction. They build the model. They take the responsibility for accuracy, fairness testing, and retraining. Compliance reviews the design and outputs to check for any discriminatory patterns and regulatory issues. Engineering owns the deployment, pipeline, And it's not a big bang release, right? Always we have to aim for a canary releases, like a A/B testing. So when your traffic is split, let some part of the traffic go through this model and some part go through the regular process and do the real-time monitoring. So is the traffic that's being gone through the revised model is performing better? Then let's start increase the traffic and study those metrics a little bit better. And how can we do that? It's all through those real-time monitoring. So when this model goes live, do you think that is just the data science project? Yeah, it's everyone's project. When performance dips, all the teams gets in the room together. They look at the same dashboard, not a different dashboard, and fix it. And when edge cases show up, nobody says that's not my problem, right? So what's the core message here? AI is a team sport. If you isolate it in a corner, you might get a beautiful model that never leaves the lab or quietly decays in production. So bring the product, the engineering, the data science, compliance, finance all together with shared goals and accountability. That's how you get systems that not only launch, but stay in the production and keep getting better. So I want to go through and just give you an overview on all the foundations that we saw. So what is the bottom line message that I want you to carry today? AI is not magic. It is infrastructure. So going through those four pillars cap, the pillar one, you need a data standardization before you analyze. Pillar two is a modern architecture. That's what makes safe scaling possible. Pillar three, governance. In regulated industries, governance is not optional. You have to build AI that you can explain and defend. Pillar four is the people and alignment. AI is a team sport, cross-functional teams with a shared ownership. So here's the uncomfortable truth. The algorithms may be 20 to 25% of the effort, the models, agentic workflows. The other 75 to 80% is your data engineering, your platform engineering, your governance infrastructure, and the organizational alignment. Here's the thing. Most organizations invert that ratio. They spend 80% of energy on the model, tuning that hyperparameters and chasing accuracy, and 20% on everything else. You know what the organizations that win? They do the opposite. They build the boring, durable pieces first. They build the data quality. They build the architecture. They build the platform infrastructure, the governance frameworks, the team alignment. Then they plug the model in. The company which is built with the technology back in their mind will success here. So if you build all four pillars, you get AI that is scalable, explainable, and trustworthy. If you skip a pillar, one of two things happen. Either your AI never leaves the lab, or it does, but eventually creates a mess. So what's the final message I want to give here for you all? Do not start the model, start with the foundation. If you're a technologist, invest in your data and architecture. They are the unsung heroes of your AI success. If you're a business leader, don't just fund data science, fund the data engineering, platform engineering, governance programs, and cross-functional collaboration. That's where the real work happens. If you're a student or an early career person, please understand that the algorithm, the 20% of the work, master the 80%, the data, infrastructure, governance, and people working in alignment. You will be far more valuable than someone who just tunes these model efficiency. So build the foundations first and then AI on top. That's how you get sustainable, defensible, and genuinely valuable AI. So that comes at the end of all the four pillars that I want to share with you with some real business use case. And I have a bonus slide, but I want to stop here and take any questions of everything that we discussed today.
Yeah, I have a question, Mala.
Thank you.
Yeah, it was really a lot of information was there. So data accuracy, that is what the foundation is. So
Absolutely.
oh, what you can suggest us means how to make sure that our data is most accurate? Is there any how to make what is the tool or how can we make sure that what the data is correct?
So the data accuracy starts with the data standardization that I was talking. So if you want to validate, if every carrier response is different, it's going to be tough for us to have those validation logic built in, right? So the validation ingestion has to be a key field, like when you input the data, when you get the data. So that accuracy has to be those validation rules. You need to clearly define your validation rules. What is accepted, what is not accepted. And you have to make sure the data is consistent across. And this validation is not like the end or at the beginning. It has to be injected into every processes. That's how you make sure your data integrity is maintained, your accuracy is maintained. And when there are issues, you log the metrics that gets logged. And it's a real-time monitoring. We are not waiting for a week to see those issues, right? There should be alerts in place. That's where the alerts come into the picture. Sometimes even carrier doesn't know that they are not responding, they are erroring. These alerts gives an eye to us, will act us to find the issues quickly. So you might miss some of the validations. There might be some inaccurate data getting into the next layer. But if we have the clear guardrails implemented, right, if we can catch it early. So it's very difficult to say I'm completely compliant on this data and nothing goes wrong. It's customer, it's user error, and everyone is a human, so the mistakes might happen. But if you have the guardrails to catch at the stage where it needs to be, then we are better served. And the metrics what we have today is not going to stay the same. So because tomorrow there's a data changes, there's a new carrier coming in, their response format is completely different. They're giving different crazy responses, right? So you need to have this guardrail re-reviewed and tightened at every step to make sure your data is accurate throughout. And that's what you feed it to your model, because if it's a bad data, your AI model is going to give you the bad predictions. Did that answer your question?
Yeah.
Thank you.
Thank you.
Are there any other questions?
So Manish has one question. You can.
Can you hear me?
Yeah, I can hear you, Manish. Go ahead.
Yeah, I was just curious. I'm not familiar much with the insurance space, so on the explainability part of your governance pillar, so I
Yes.
just wanted to understand like what kind of regulatory oversight is being
Yeah.
tackled in companies.
So
Yeah.
the explainability, I can give you a very overview what the definition is about. So when we started the presentation, I gave you a couple of examples that happened, right? So the claims got denied. And when the reasoning was to be provided by the carrier, they missed the part. So what that means is if you're deploying a model, right? And if the model is what you trust to make the decisioning, have you got the model documentation done and approved in your governance? In a way, if the process is doing this, this is the input that comes in, this is exactly the process it goes through, and these are all the factors through which the decisioning was done. In the insurance space, the underwriters are licensed persons who are capable of making that decision. When you swap that with the model is equally capable of making that decision. If you have clearly documented the process, the model documentation, and if you have the governance guardrails to say, this is how this model has estimated the premium or the price, or in a price comparison world, this is how we shown them the top price on the list. That is explainability. So when there is a question coming to you from a regulator or from a customer or from a carrier, do you have the data traceability to prove what happened as a moment of truth? And do you have that explainability feature built in to say, this is how the model has actually performed to arrive at this decision? If you can explain your decision and if you can defend your decision, that's explainability. That's what the government would like to say. See, when we hear the word governance, we all get afraid. It's nothing to be. So you need to have a clear documentation. All they are explaining you is, sorry, all they're asking you is explain your decision, right? That's explainability. Did that help?
Yeah, that does. Yeah, thank you so much.
Thank you.
Thank you.
Are there any other questions? Hope I was not too into the insurance space, right? I want to just take one use case and give an overview, but these 4 pillars are definitely important. Think about from your space when you want to do this.
Yeah, we got a really good one. insights that how when we go and find the car insurance quote, how it was. So that was really
Yeah.
good
I,
one. How
thank you.
they process our data. Yeah.
Thank you. Yeah, I did not want to go into the process because the aim of the session was to cover the pillars. So I was planning to do that way, but we can always go back. If you have any questions on any of the slides that we saw today, we can still go back and take it if we have time. Hey, Alan.
Hello. Just a general comment. I think you gave one of the best presentations I've seen on the big picture of making sure that you end out with something that's defensible, something that's explainable. There's so many people working on this latest AI thing that but they can't tell you why it came up with the answer that it came up with, and it may have hallucinated all over the place. And as we begin depending more and more on AI, things like what you talked about are going to be critical as to whether it becomes a helpful ally or an absolute disaster. So I think you did an excellent job of giving an overview of that.
Thank you so much, Alan. You made my day. Thank you, everyone, for also having those active participation. Yeah, so 2030, right? So you would see those stats, everyone saying by 2030, this is where our industry would be. Definitely, I'm not an anti-AI. I use AI tools a lot. There's a lot of AI-assisted tools. In fact, we can even have another session on that. There's a lot of AI gems which really made some of those repetitive tasks easy. In fact, some of the slides that I shown you today, the diagrams, I used a tool to generate it because I didn't really have time to put this all together in a short time frame. So we can even talk about those AI gems. We are calling them as AI gems. That's a new word for it. But when you come into this regulated industry, then you have to be very careful on where you're applying your AI. It's nothing wrong. You can make your underwriters replace with this AI decisioning, but you need to know what you're doing and you have to be explaining it. Explainability is what this insurance regulations are really focusing on. Okay, I see we have a few more minutes and I want to take you to the bonus takeaway if there are no more questions. Okay, so that's the last slide, I promise. Yes, so far we have been talking about AI, how to implement AI, right? This might sound counterintuitive. Not every problem deserves AI. I mean it. I know that sounds contradictory after I have spent so many minutes talking about building the case for a strong AI foundation. But here's the reality. Some problems are just solved faster and better with the existing tools. AI is powerful, no doubt, but it is not free. It's an expensive implementation. So when to not use AI? If you can answer a question with just a simple query, right? That's just a select statement. You go through your data, just query the data and give the output. Nothing needs to be a machine learning project. If you do not have enough data, the model predictions will go wrong because the model needs those thousands of millions of data to categorize. There are so many parameters it has to run through in order to get to that prediction accuracy. If you're just starting and if you do not have enough data, predicting the churn for 50 customers, just talk to them. At that scale, your insight is mostly noise. And if you cannot explain the decision, Alan made a beautiful point there. If you cannot explain the decision, why the claim got denied, and to answer Manish's question, how do we know this is happening in the right way? If your only answer is because the model said so, then you're not ready for the regulators or even for the customers. So if the decision is high stake and irreversible, right, you're making a life-changing decision, then that decision, I would say, should still stay with the humans. AI can flag the risk, but it can do all the analysis up until that moment, but the decisioning should be the proper authorized licensed person to take. AI should not be the sole decision maker, but if your model is explainable and you can defend your decision, maybe go for it. So when do AI does make sense? Don't we have an industry that successfully adopted AI? No, we have. But what do they all have? Data. They have a real scale, thousands of millions of data. And their scale volume also demands them to make those repetitive decisions. The patterns are too complex for rules, dozens of variables, all nonlinear interactions, nothing is straightforward. And their success is measurable. They have a before and after metrics, their conversion, their loss ratio, and their cost per bind, the time they save. And the errors are low cost and recoverable. Bad ranking that users can easily be corrected, but not the critical claims denials. So now if someone comes to you and asks, can we use AI? I would recommend your first answer shouldn't be yes or no. The right answer is question back. Okay, if we have that, what would it do differently? What problem are we trying to solve? If they can't describe that concrete action, then the problem is not an AI problem yet. It's the problem definition problem. The lesson, sometimes the most impressive AI project is the one you never built because you solved the problem a simpler way. So one of the best advice that I received at the start of my career is the problem might be complicated, but the solution doesn't need to be. If the solution is becoming complicated more than the problem that it is trying to solve, then you're on a wrong path. Step back and rethink your approach. You just don't need a jackhammer to drive every nail, right? A simple hammer will do. Or in the AI terms, if I want to rephrase that, just because you have a machine learning hammer doesn't mean every problem is your neural network nail, right? So pick your battles. Most problems don't need AI. Some absolutely do. But the real skill is knowing the difference. Thank you. There comes to the end of the presentation. So thank you for spending time with me to know what it takes to make AI work in the real world. If you would like to continue the conversation, please connect with me on LinkedIn. And I'm always happy to swap notes on data foundations, architecture, and responsible AI in insurance. I'll stick around for any more questions. I think we have 2 more minutes, but would love to hear from you. Thank you. And thank you, Alan, and the Computer Society chapter for giving me this opportunity to share my experience with the team. Thank you.
Thank you, Mala. So before we end, we have 2 minutes. So let me share my screen. Can you see my screen?
I stopped sharing.
Yes, we can.
Yeah. So if anyone is new to IEEE, so they can join IEEE with this link, which I shared here. So IEEE.org/join. And thank you, Mala, for the so much information was there, really helpful. Everyone, I'm 100% sure that we learned a lot from this session.
Thank you.
What is next? So I just wanted to let all our audience know that this is not the end. We just started this webinar series, and we are going to conduct many more in upcoming months. So if you are interested to join us, if you want to share your knowledge, participate in IEEE chapter sections, then yeah, you are most welcome. So, and there is another link which we are going to send you. You can do the anonymous survey on the topic which we covered today. If you are interested on more new topics where you want to hear, you want to learn, and you want to be the part of it, yeah, you can share that through that anonymous survey. And if you are interested to be a speaker like Malar and recently what we had with Miss Rajni, so you can reach out to me and Malar. So these are our email addresses. Yeah, just note down those email addresses. You can send us your brief about your bio and LinkedIn profile and the topic on which you want to speak and your abstract. So our committee will go through all of your information, and we will let you know when you can present if you get selected for on the topic. It depends on the audience priority, what they really wanted to hear, or the schedule and all. But yeah, you are most welcome to send us all your expertise areas where you want to present. That's it. Thank you. Anything else? If I forget, Alan and Mala, you want to say?
No, you covered it all, Devendra. That's great. So we would like to see more presentations like this, and we want to see what topics you would be interested, right? So we want to make sure we bring you what you want to see. So please use that survey link that we are going to send and show your interest. Like if you want to be a next speaker, please send, like Devendra mentioned, and based on the interest that we gather, we definitely want to keep up the momentum as we get into 2026 and beyond. And we will like to present more technical insights to you, and we want to see you from you too. So if you would like to be a presenter, right? Thank you so much for everyone joining this session. Is there anything, Alan, that I missed?
I think you did an excellent job. And as I said, I think it's one of the best presentations I've seen on the topic. So it ought to be required viewing for all new students and people just starting on AI to make sure that they get their head in the right place to begin with.
Yeah, thank you. And thanks for all the heartfelt comments. And thank you very much. Glad I made your time. I did not make you to be miserable on this holiday time. So happy holidays, everyone. And you all have a wonderful new year. And we will come back with more exciting topics in the new year. Thank you so much.
Thank you
Thanks,
so
all.
much for having us. Thank you.
Devendra, I just want to quickly, I may be connecting you somebody I'm Vandana from Nova V Affinity Group. I may be connected to one more person who's interested in speaking. We are having like an in-person event next month, but I think this will be a good platform for her to showcase her, knowledge. So, it's really good. I'll send an note to you guys and introduce her.
Please. Yeah, thank you.
Yeah,
This
definitely.
is really good, Malar. I'm like amazing session,
Oh, thank you, Vandana. Thank you so much coming off mic and telling
AI is becoming such a hype these days that everybody's thinking just want to jump on a train without knowing a lot about it. And your session was great, knowing that AI is not everything. Obviously you have to make that call very considering all the factors, not just say, oh, let's just jump on the AI train. So it was very informative. Thank you so much.
Thank you so much. You made it clear. You summarized it well. Yeah.
Thank you.
Thank you.
This concludes our session. Thank you.
Thank you so much, guys. Take
Bye.
care. Bye.
Thank you. Bye.